What if I told you that right now, China is developing a train capable of reaching speeds of up to 1,000 kilometers or 621 miles per hour? This train moves so fast that it could get you from New York to Los Angeles in just over 2 hours. Japan's famous bullet trains, Shinkansen, typically operate at speeds of around 200 miles or 320 kilometers per hour. And the fastest commercial maglev train currently in operation, the Shanghai maglev, reaches a top speed of 268 miles or 431 kilometers per hour. Now, imagine a train that more than doubles these speed, faster than many commercial airplanes, which cruise at about 575 miles or 925 kilometers per hour. Think about this. You could travel from New York to Chicago in about 90 minutes. Right now, that same trip takes you about 12 hours by train or 2 hours by plane. And that's not counting all the airport hassle. In our modern world, we're always looking for ways to make things faster, more efficient, and more connected. We've gone from horse-drawn carriages to cars, from propeller planes to jets, and now we're on the brink of something that could make even our fastest trains look like they're standing still. This is the T-Flight Maglev vacuum train, a technological marvel that's going to rewrite everything we know about high-speed travel. But before we get into the details, first, let's take a quick look at how we got here. Trains have evolved significantly since their early days. When steam engines first appeared, reaching 48 kilometers or 30 miles per hour was considered fast. This was a big improvement over horse-drawn carriages. Cars followed, typically going 64 to 80 kilometers or 40 to 50 miles per hour, which seemed quite fast at the time. In 1964, Japan introduced its first bullet train, the Shinkansen, which could travel at about 210 kilometers or 130 miles per hour. This was a game changer, allowing people to cover long distances in much less time. These trains have since improved, with some models now reaching speeds of 320 kilometers or 200 miles per hour. More recently, in 2004, China unveiled its first commercial maglev train in Shanghai, hitting speeds of 460 kilometers per hour. At the time, this was revolutionary. The train connected Pudong International Airport to the city center in just 8 minutes, covering 30.5 kilometers of track. But for China, this was just the beginning. The Shanghai maglev, while impressive, was built using German technology. And if there's one thing we've learned about China over the past few decades, it's that they don't like relying on foreign tech for long. By 2016, China had developed its own maglev system in Changsha. This train was slower, running at about 100 to 120 kilometers per hour, but it represented something much more significant: China's ability to develop and build these systems independently. The Changsha line cost about $750 million to build, and while that might sound expensive, it's actually relatively modest compared to other transportation infrastructure projects. The line carries 363 passengers per train and has been running successfully for years now. Each of these developments marked a big step forward in speed for its time. They changed how we think about travel, commuting, and city planning. Cities that were once far apart became more connected, and commuting long distances became more possible. Seeing this progression helps us understand the new technology better. It shows how transportation has kept evolving, with each advance building on the last and expanding what we can do. Fast forward to today, China's Aerospace Science and Industry Corporation decided to step in, and they're not just trying to make slightly faster trains. They're aiming to completely revolutionize how we think about ground transportation. The new system they're developing targets speeds of 1,000 kilometers per hour. That's nearly the speed of sound. To achieve this, they're combining two technologies: magnetic levitation and vacuum tubes. Now, you might be thinking, wait a second, isn't this just like the Hyperloop that Elon Musk has been talking about? Well, yes and no. While both technologies aim to achieve super high speeds using low-pressure tubes, they're actually quite different in how they work. But we'll get to that in a bit. Think about it this way. What's the biggest thing slowing down any vehicle? Air resistance. As you go faster, the air becomes like an invisible wall. That's why the current fastest trains top out around 500 kilometers per hour. Beyond that, you're just fighting against the air. This new high-speed train runs in a low vacuum environment. This dramatically reduces air resistance, allowing for those incredible speeds. So, what exactly is maglev technology? Well, maglev stands for magnetic levitation. It's a method of transportation that uses powerful magnets to lift and propel trains. Instead of using wheels on a track, these trains float on a magnetic field. The concept of magnetic levitation isn't exactly new. It's been around since the early 20th century, when Robert Goddard and Émile Bachelet first proposed using magnetic fields for transportation. But it's only in recent decades that we've seen it put into practice. Now, let's break it down how this system actually works. Traditional maglev trains float about 10 millimeters above the track. However, this new system, it levitates 100 millimeters. That's 10 times higher. This increased height reduces interference and allows for more stable operation at ultra-high speeds. The trains themselves are being built with carbon fiber materials to reduce weight while maintaining structural integrity. This isn't just about going fast. It's about going fast, efficiently. The superconducting maglev system they're using is particularly clever. When certain materials are cooled to very low temperatures, they become superconductors, meaning they can conduct electricity with zero resistance. This makes the magnetic levitation much more efficient and stable. Now, you might be thinking, this all sounds great on paper, but does it actually work? Well, they've already started testing, and the results are promising. In Shaanxi province, they've already built a 2-kilometer test track. Now, 2 kilometers might not sound like much, but it's enough to test all the critical systems. The test results aligned closely with their theoretical predictions. It's one thing to do the math and say something should work. It's another thing entirely to see it actually perform in the real world. During the test, they focused on several key aspects. First, controlled navigation. At such high speeds, even the slightest deviation could be catastrophic. The system needs to be able to keep the train on its exact intended path with incredible precision. Second, stable suspension. The train needs to maintain a consistent height above the track without any wobbling or fluctuations. This is crucial for passenger comfort and safety. Finally, safe stopping. Being able to go fast is one thing, but being able to stop safely is just as important. The test demonstrated that the system could bring the train to a controlled stop from high speeds. These tests have proven that the basic concept works. The next step is scaling it up to longer distances. Let's talk about what this means in practical terms. This kind of speed could create what economists call one-hour economic circles, massive urban clusters where any 2 points are no more than an hour apart. This could completely change how people live and work. Imagine being able to live in one city and commute to work in another city hundreds of kilometers away. It could make long-distance relationships a whole lot easier too. Cities that are currently hours apart could become as connected as different neighborhoods in the same city. There are also some significant environmental benefits to consider. If these trains can replace short-haul flights, we could see a substantial reduction in carbon emissions. Air travel is a major contributor to greenhouse gases, so any technology that can offer a cleaner alternative is worth paying attention to. To put this into perspective, a typical short-haul flight might emit around 150 to 200 grams of CO2 per passenger kilometer. In contrast, even conventional high-speed rail emits only about 20 to 30 grams. Maglev vacuum trains, being even more efficient, could potentially lower this even further. But let's pump the brakes for a second. As cool as all this sounds, there are some significant challenges to overcome. For one, the infrastructure costs are enormous. Building low vacuum tubes over long distances isn't cheap, and integrating this system with existing rail networks is a complex task. To give you an idea, the cost of building conventional high-speed rail lines can range from $17 million to $170 million per kilometer, depending on the terrain and other factors. A maglev system in a vacuum tube would likely be even more expensive. We're talking potentially hundreds of billions of dollars for a single long-distance line. Safety is another crucial consideration. At these speeds, even tiny issues could have serious consequences. The emergency systems need to be absolutely foolproof. It's worth noting that China isn't the only country working on this technology. Japan has been developing its own superconducting maglev system, the Chuo Shinkansen, which is designed to run at speeds up to 505 kilometers or 313 miles per hour. While not as fast as the proposed Chinese system, it's still a significant step forward and is actually under construction, with plans to connect Tokyo and Nagoya by 2027. In the United States, several companies are working on Hyperloop technology, which shares some similarities with the Chinese maglev system. While progress has been slower, there have been successful tests, and several states are considering Hyperloop projects. The main difference between Musk's Hyperloop and China's T-Flight lies in their design and goals. Both are high-speed transportation concepts, but they take different approaches. The Hyperloop aims for speeds of 1,200 kilometers or 760 miles per hour using pods in a low-pressure tube, while the T-Flight targets 1,000 kilometers or 621 miles per hour using maglev technology in a tube that doesn't need to be near vacuum. The Hyperloop is still mostly on the drawing board. Even Virgin Hyperloop gave up on passenger transport, while China's building on their experience with maglev trains. While similar projects have grabbed headlines in the other parts of the world, China's approach of evolutionary development, starting with conventional maglev and gradually pushing the boundaries, might prove more successful. So, what do you think? Are you ready for a world where you can zip between cities at the speed of sound? Or does the idea of traveling that fast make you a bit nervous? Let us know in the comments below. As for me, I can't wait to see where this technology goes. The idea of being able to have breakfast in Beijing, lunch in Shanghai, and dinner back in Beijing all in the same day is mind-blowing. Who knows, maybe in a few decades, this kind of travel will be as common as taking the bus is today.